My name's John Gleeson. I'm Chief Operating Officer for Storj. I have with me JT Olio, our Chief Architect, and we're just going to sort of keep this conversational and fluid, but we're here to talk about Storj and what potential opportunities we see to work with the Filecoin ecosystem. Just sort of quickly here, we ran into some Filecoin people at DWeb Camp, Reba in the back there, and just kind of started going through like, hey, what do you do? What do we do? Where are the potential synergies? Is it competition? How do we fit in the ecosystem? And our perspective has always been that, within the decentralized space, all cannons should be pointed at Amazon because that's where that's the true enemy. And a rising tide lifts all boats, as JT said this morning. In terms of, when decentralized systems succeed, right, it builds credibility for the space as a whole. And if we're pointing the fingers at each other and the cannons at each other, we're just doing Amazon favors. And also, for those of you who did or didn't see the Banyan presentation this morning, like spot on, +1, maybe +2. Like that was just really good in terms of their feedback from customers, and that's a lot of the stuff that we've heard over time. So just starting off with a quick question here. Just from this group, and we've heard a lot of stuff here around like friction and onboarding stuff, but just a couple of shout outs on biggest barriers to Web3 adoption.
Ignorance.
Awareness is huge.
Service of fiat value. I mean, like you said during the Banyan presentation, nobody pays for virtue unless you're a philanthropist, and we pretty much tapped all the philanthropists in the data sphere.
Yep.
And now people are looking for solutions.
Yeah, that's spot on, right?
Complexity.
Oh yeah.
Say SLA, if you want to go out and get any kind of enterprise, you're going to have an SLA, so it's not, a science experiment. Otherwise, you can go do stuff, right?
Oh yeah.
Not meeting users where they are.
Yes. Yes to the 10th.
Trust.
Yes. All that. Oh, all those things. So, we've seen similar things, right? Common space, similar challenges, right? For us, it's always been a matter of lack of compatibility, counterintuitive UX, slow, unreliable. Like if that's what's in the thought bubble over people's head when it comes to Web3, right? You have to tear all those barriers down. Everybody sort of looks at this Rube Goldberg machine design there, but everybody sort of looks like, boy, this sounds harder than where I need it to be. And so that's kind of where we've been focused. And when we look at the market size, right, Juan had something up that looked very similar to this, but basically all of the dollars and all of the workloads are all in Web 2 today. And to bring that over to Web 3, incumbents have a 15-year head start, right, and they have billions of dollars. But there's a lot of innovation in Web 3, and that's going to drive a lot of the things that we talk about today in terms of like how do you go disrupt that. And decentralized architectures can be very disruptive, right? So we can disrupt on price, on performance, that is sensitive, privacy, compatibility, data expansion, like just a range of things that are inherent in the architectures, right? Because when you can spread a workload over existing equipment that's already being spun, powered, and cooled, you can win. So I'm going to turn it over to JT to talk a little bit about just more technically about some of the same things we're seeing and areas where we've got some synergies and differences in how we've approached it.
Yeah, I think the main takeaway is that Filecoin and Storj are looking at trying to bring decentralization to the masses. There's a collection of problems in that space, and there are a couple of different ways to solve them, but they're the same problems fundamentally. The same problems are around how you keep track of where you put the data. The same problems around how do you trust nodes? How do you verify that the data has been stored correctly, right? And so, there's a couple of different ways in which I've tried on the right-hand side is Storj, and on the left-hand side is Filecoin. But Filecoin keeps track of sectors on the blockchain. That's how we keep track of who is responsible for the sectors, is keeping track of the audit reports within the Filecoin blockchain. There's an allocation table and an order book, as the paper describes it. Storj has those materialized in the sense that you're talking with a heavy client that we call the satellite that keeps track of those things so that you can have under 100 millisecond responses to some of these aspects. there's the ahead of time proof of replication, proof creation, and sealing process to make some of these decisions secure and efficient. But Storj uses stochastic auditing, which from a consumer perspective and from a security perspective, we found works just as well, but is able to have on-demand immediate streaming both in and out. So storage markets and retrieval markets, we have at-rest billing and egress billing. It's similar concepts. We're solving, similar problems here. We have an optimistic protocol for fair exchange, which, I know there's been some conversations about retrieval markets. We've implemented some of the literature on those types of things. So to turn it back over to John.
Sure. So as we were sort of looking at how we can be disruptive in that market, right, we wanted to really start with the biggest market. And so we looked at AWS, Azure, GCP, and our sort of outcome that we were looking at was how do we get customers to migrate from the hyperscalers? Like, what is it going to take to move the needle on them, right? And we can come up with a lot of value propositions around reducing cost and increasing privacy and security and all of those good things. But with all of those value propositions, one of the things that's come up over and over again is nobody buys decentralization, but people do buy better actual quality storage. And so if the problem is that they need to store data in an archival way for a long time in a way that's provable, and it is immutable, and it is censorship resistant, and it's also ransomware resistant, that's something that somebody will buy. And in our case, it's very similar. Whatever they're paying for Amazon is too much. And so we're finding a lot of real good value props around just providing an alternative to Amazon on their footing, leading in with price. So we got sort of a couple of parts to this. The first one is I just want to kind of go through an intro to storage, how we talk about ourselves to the market, and then sort of what's resonating, what use cases and things like that. And then we'll sort of tee into how does that tie into where we can integrate potentially and create value props for the Filecoin ecosystem. So when we talk to customers, what we lead with is we're enterprise grade, globally distributed cloud object storage. We don't say decentralized. We don't say crypto native. We don't say blockchain. We don't say any of those things. We make sure that we're talking to the enterprise in words they can understand. They know what decentralized means, and they don't like it. But they also know what distributed storage means, and they like it. But they also have things in the thought bubble over their head. They're like, ooh, expensive, hard to maintain, sounds challenging, but high durability. And then we just are crystal clear. We're a drop-in replacement for Amazon S3, lower cost, better performance, much better carbon offset. And our customers find that when they test us, they're actually typically 2 to 3 times faster for their use case globally. We talk a lot about, sort of our security and privacy, our zero trust architecture, global performance again, and we just use the language of the enterprise, and we try and lean in, right? So we become easy to buy, easy to understand. That's kind of a critical thing for us. But we have sort of this dichotomy, right? On the Web 2 side, very enterprise friendly. We're like the mullet of Storj, right? We have, party out back, all business up front. But the idea is we're this S3-compatible object storage, and we look just like every other service, but just a little better on the key things that count. And then on the Web 3 side, we also offer things like an IPFS gateway, right? So we have those compatibility layers that people are familiar with that distributed and decentralized backend. And that concept of Web 2, Web 3 bridge that comes up all the time, this is something that's really important for us because we'll hook them with the S3 gateway, and then we'll expose our peer-to-peer transfers for higher performance. So we have a number of different use cases we're seeing in the market. A lot of these things are in like the M&E use cases, big files that have to move around a lot to get streamed by a lot of people. These are things that are really favorable to distributed architecture, right? Tiny files bad, big files good. Lots of changes bad, upload once and download many times, worm use cases, super good. So we see cloud native applications for just images and catalogs and things like that. We see a lot of scientific data storage use cases, so moving big scientific data sets. And then backup is just kind of a bread and butter use case, right? Everybody needs it. We find that we are really good for backup and retrieval because of our consistent and fast speeds globally. So just by the way, we are kind of like we promised to be conversational, but we're not. Feel free to ask questions or throw things along the way, but let me kind of pause here on use cases and just see if anybody wants to dive a little deeper on what we're seeing in the market and who's using us.
Your collaboration with TrueNAS, if I'm correct,
Yeah.
was one of the best marketing things I saw in a long time.
Thank you. So fun fact, that took years, right?
Oh, I'm still wondering how you pulled that off.
So I started with Storj in 2017, and I want to say it was within 6 or 8 weeks of joining, right? We had a hypothesis originally that supply was hard to find, but demand would be easy. Ha, ha, ha. So as it turns out, supply is actually easy to find. But we looked at the TrueNAS ecosystem, like, oh, open source, really friendly. They have petabytes of demand, petabytes of capacity. We could just dip our toes in there, and one customer would bring us right across the finish line. And we called them up, got a call. They talked about what they did. They had attempted to run a node. It had tipped over. They had attempted to store data. They were like, it worked, but it wasn't the shape that their customers would want. And they said, okay, we're going to keep an eye on you. And when you're ready, we'll let you know that you can talk to our enterprise customers. Well, we don't put anything in the ecosystem that will jeopardize our customers' data, right? They were just like flat, like super lovely, loved the thought, but no. And about every 6 to 9 months, I would send an email saying, hey, what do you think? No. Like, no, for years. And then finally, we were out in San Francisco for a show, got an email from their head of business development. It's like, we've tested you and you're ready. Let's have a conversation. And it was a combination of the performance and the durability and all that stuff that made that happen. But a lot of these enterprise these deals, if a typical enterprise sale is 6 to 9 months, call it 9 to 12 for decentralization, because you got to get your foot in the door to have them even talk to you, and then you got to go sell all the rest of the stuff that everybody else does. That one was egregious, but I was the first one. But yeah, that one's been extremely successful in terms of pure demand side. We haven't even tapped that for supply side at all. Yeah, very exciting one. Love that. Close to my heart. But there are a bunch of other prospects and customers out there. So we have some Web 2, some Web 3, some really good things. And we're sharing the deck, so you guys don't have to write too much stuff down. But a lot of these things you'll see are actually technology partnerships. They're backup applications that we integrate with. Yes?
What percentage, divulging too much, what percentage of your business is partner versus direct?
What do we partner now? About 30 partners, 70 direct?
Yeah, so 30 partners, semi-direct in terms of hits, but in terms of dollars, it's actually now Storj towards partners, just because there's so many other people on the street. And customers, they want to buy a backup solution that works well. So they want to buy a Cronus that backs up Storj, as opposed to buying a kid.
Yeah.
Yeah, and I think someone here said the people buy solutions, not products. And yeah, I mean, that's how you get theirs with partners too.
So I don't know if you have on the next slide, but for video editing, right, we partner with that, right?
Because that's who you want.
That's who they want,
Yes.
right? And
Yeah.
if they want to
Got it.
use Splunk, and they want to use Dribble, they go with Splunk, right?
So do you have an inbound engine that takes in lead flow, or?
Yeah, yes, we have,
Yep.
we have a Salesforce and inbound engine, but we optimize for partners, which just means, we have to be very standards based, and they have to make sure that we're, durable, we have these files, and we're high performance on, but now it's much more exciting.
Cool. Let's do that.
Yeah, and this is kind of just an interesting talking point because, if you look at the other players there who tried to sort of chip off some Amazon business and just go, oh, look, that, but cheaper. You have Wasabi and Backblaze as the two principal examples, right? And what did they do? They offered a product that was cheaper, but it was effectively the same architecture, right? We're going to build buildings, stuff it full of servers and hard drives and do the same thing, but just try and stay low cost, low margin. And then they went like channel led, big blitz on channel led.
Yeah.
And so the thing with channel led was you got to get a couple of those first customers across the board. So channel looks and goes, oh, this is worth my time. I'm going to sell something. I will be successful. And so that's an area where we built the thing. We got a few early, customers to show the way. Then we got the technology integrations with the products, and now we have the systems integrators and the partners who resell those things, and now we're in that solution mix. And I think that's a huge portion of what's been fueling our growth probably the latter half of this year, especially, and it you know, it only looks better after that.
Sorry, what was the main driver you said?
So,
Getting some early wins.
yeah, you get the early wins, right? So this is like enterprise sales, like basic approaches. You get the win, you make them referenceable, because nobody wants to be first, and boy, do you give the cousin deal to the guy who goes first. But the next person who comes along and says, "Who's using you?" JT's using us, and they're like, "Oh, I know JT. He's awesome. If JT trusts you, I trust you." And then when you have channel partners, they're like, "Okay, how hard is this going to be to use?" Well, we work with all this stuff and all these guys. Oh, I know those guys. This is going to be pretty easy. Yeah. Like it's just sort of reducing those barriers. The first one that takes you through the compliance ringer, you spend all day there, but then you figure out how to talk the talk. And the second one you go through, it's way less painful. And then once you have a referenceable customer who everybody knows took you through that ringer, they're like, "Oh, you got through that? Yeah, just send me the paper." Yeah, feels like an A.
Yeah, your first channel, sales enablement, the first time you go to market with a partner, it's really
Yeah.
painful, but then it becomes repeatable.
Yep. Yeah, and people want to redline your like security documents. Like, no, these are my security documents on the first go around, and the next go around they're like, don't even read it, because they assume that the person that just bought it from you already read it and that you're good to go. So like there's a flywheel effect to enterprise sales in general, and where we're seeing that next is in our 4 key verticals, right? Media entertainment. We're in POCs with large studios. Why are we there? Because one of our channel partners used us as the back end and stored some of the video production work for Ahsoka. So when you're like, we had Disney data on our service. Like, you had Disney data on your service? Oh yeah, right? That makes it that much easier to sell. It makes you easier to climb upstream, because if you're trusted by them and you didn't screw up, you get trusted by other people. Same thing in financial services. Banks are like, love everything about you, your security store, everything but the cloud. And so we've looked at hybrid cloud environments, very similar to sort of what the last group is doing with the sort of, yes, building out that hybrid infrastructure is great with financial services. But the strong encryption, the zero trust, the control over the data, like, they just love it. Healthcare is the same thing, right? Onboarding our current first major multi-petabyte IBM takeout in healthcare space. Everybody else who follows will just check the box like, "Oh, you work with them? Don't even need to read it."
Are your resellers reselling the same thing, or have you packaged different solutions per reseller depending on who they service?
Yes. So we have kind of three different categories. There's true SIs, like systems integrators. Those are the ones we're typically going to market with on the sort of hybrid environments. We have resellers who resell like some of the software packages that you saw, a lot of the backup providers who are just bundling. And that's a matter of just like rev share or wholesale discount. And then we also have private label solutions. So people who are offering object storage, but it's their object storage and it's packaged with value-added services.
And do they price it themselves, or do they do cost of what price you give them?
It depends on the service. So most of the value-added service ones are a higher price point because they're bundling in, support and onboarding and all, and migrations and all of that
They
stuff.
just determine whatever price they want.
We just set a minimum. Yep. And then those are wholesale pricing because they're private labeling, so it's just volume-based discounts.
But you control the wholesale price.
Yeah, so the important thing is that Storj is a decentralized network, and we get into the next things. I'll have JT kind of talk about the peer classes a little bit. Multiple peer classes means you get multiple points of entry. So if I can put a pin in that thing there, because then we'll come back around and then it'll make sense. You're like, why does Storj control the price for the whole network? And it's, we don't. But we control the price for the components that we run, where there's 20,000 storage nodes sharing capacity. There are less that are running what we call the satellite, which is a metadata server. We'll talk about all that stuff and kind of all will become clear.
Okay.
Okay.
One question, so when you work with these partners,
Yeah.
it's always through your S3 integration,
So
or you make some specific development for them?
S3 is the gateway drug, right? Everything works with S3, and they know how to do it. So they'll start with S3, and then what they'll find is they'll want to do the native protocol after that, where it makes sense, because nobody wants to hire a team of developers and rewrite their application to work with something new. But if it's just, it works with S3, I just change my endpoint and it works with you, that's cool. Everybody knows how to do that motion. And then GB Labs is a great example. They are a media production workflow application, and what they did was they did the S3 integration, And they're like, wow, this is really cool. This is fast. We're able to offer a Lucid Link alternative. So they have a cloud product called Nebula. Nebula is backed by Storj. And then they were like, well, can it go faster? We're like, well, yeah, if you want to do a native integration, sure, here's the library. They actually built a native integration, so they upload through our S3 gateway, but they download peer-to-peer native transfers. You could max out any kind of local network you've got when you use our peer-to-peer transfers. That's in Web3, that's like what everybody does because it goes so fast. But it does require development work, and they had to prove the value first, like, does it work? Can they sell it? And then can they differentiate because it's so fast? So that's the pattern we see. This is just kind of your, hey customer, this is what we show you on your value, right? So proof of value is, what's it cost to store a petabyte of data for a year, right? And so on Amazon, it's this much. On Wasabi, if you really want like multi-location, no single building risk, that's the picture of the OVH data center building burning down on the left there. If you're gonna punch hard. And then we have Storj, right? The little bar down there. And so what we're able to say is, hey, look, we can offer you the 11 nines of durability, the faster performance, all the things you've come to love at a price point that's even lower. And then when Wasabi and Backblaze raise their prices, you're like, oh, thank you. Come on. Throw me a challenge. Come on, make it hard. But no, please don't. So there are other things that are just table stakes, right? So we can differentiate on some of those things where we're winning. We can sort of skirt around some of the things that are less good for us. But there are some things where like durability, right? If you are at risk of losing data, everybody will just have the conversation, be like, here's the thing. Nobody gets fired for choosing Amazon. De-risk this for me. Tell me how I'm not going to get fired. Oh, well, we're not going to lose your data. Here's our whole story on durability. Here's our whole story on auditing. And here's our whole story on repair and all of that good stuff. Love it. Security. Okay, you're storing data on thousands of different endpoints. Tell me how that my data is going to be protected in that way. Okay, great. Well, we use authenticated encryption, and it's quantum resistant, and we have a great story there. Availability, right? We have to offer an SLA. If you don't offer an SLA, they don't take you seriously. And then scalability, right? When they test you, if you tip over, that's bad. And then ease of use, right? We talked about that. If you add friction to their onboarding, they're going to give up, and they're going to get bored. So I talked a lot, and I'm tired. Let me turn it over to JT, who can talk about the different components of the network.
We have a rich network. And in this rich network, there are three main, we call them peer classes, but they're just types of nodes in the network. Our storage node network is predominantly consisting of our storage nodes. And our storage node requirements are pretty low, actually. The main thing that storage nodes need to do is return the data that they were given. And so for that reason, storage nodes run the full gamut of Raspberry Pis all the way up to Blade rack-mounted servers and data centers. What they need to do is return the data that was given to them. We have some cryptographic challenges to make sure that they keep the data. We have another service that I'll talk about. So actually, we're talking about the full clients. When someone signs up for storage, they are either choosing an existing full client or getting their own. We have a large university that set up their own full client. We have some of the bank operators have set up their own full client. If you sign up on our website, the easy flow that happens for onboarding for users, you get a full client chosen for you. But that full client doesn't have access to any of your data. It's just responsible in the style, if you're familiar with Kademlia. Kademlia has a sort of ownership model where the client that is responsible for storing the data is also responsible for maintaining, double checking that the data is still there. And so in that vein, the full client for us, which we call a satellite, is responsible for doing audits and checks. And it's not just a single server, it's a cluster of servers. And then we have our light client, the uplink. And the uplink runs the full gamut of an embedded JavaScript or an embedded Go library that can be compiled to WASM, but it also can be a hosted edge gateway that mimics the S3 API. What happens when data is uploaded is it hits our light client, and that could be a gateway, so it's just over HTTP. That data is encrypted. Very first thing that happens out of the gate is it's encrypted. It's encrypted streaming. Everything happens on these boundaries that we call stripes. So as it marches through, there's no staging area. It's not getting processed. It just comes through in one go. So in one go, it comes through, it gets encrypted. Some of the stripes get, all of the stripes, but in this pipeline, they get Reed-Solomon encoded with erasure coding. And then that erasure coding gets stored out onto nodes in the network. Then we have to keep track of where those nodes were. That would go into our materialized allocation table essentially. But that could, if there was a deeper integration here, that could go onto the blockchain or something like that. And then when you're downloading data, it's the same thing. You can download the middle 5 kilobytes of the object that you just uploaded immediately. There's no transformation step that happens later. What happens is you pick the range of data, you go ask those nodes for that data. We have a egress payment system so that they get paid for their bandwidth. That data gets sent back, it gets reassembled because it's happening from all the nodes concurrently, and then it gets decrypted, and then the user has their data within 100, 200 milliseconds. All of our latency profiles were measuring on the order of milliseconds. So we have really fast retrieval. I talked a little bit, I tried to ask some questions at the working group, and I did a poor job of it, to be honest, if you go watch the recording of the working group later, if you weren't there. But essentially, we started off with some observations. The first observation we started off with was this paper, which says that there are fundamental requirements about any distributed system. The upshot of this paper, High Availability, Scalable Storage, and Dynamic Peer Networks Pick 2, is that it's not disk space you're constrained by, but bandwidth. And the reason for that is because hard drives fail and data is always on the move. And because data is always on the move, because drives fail, if you're going to do repair, you have to be very conscientious about that all of your data is just constantly moving, which means that you have to minimize the amount of bandwidth usage as much as possible. When you do replication, you are trading off bandwidth for durability. If you make 5 copies of something, that means you can lose up to 4 and you can still get that data back. And the expansion factor is, in that case, 5, right? So you have like 1 terabyte turns into 5 terabytes in the network. We're using erasure coding, which allows you to get rid of that dynamic. And so the expansion factor is no longer tied to the durability. If you have an object and you break it into 20 pieces and you over encode it, so there's 40 total, any 20 of the 40 can recover the file, that's a 2x expansion factor. That has the same durability, given the churn of the network, as a 4065 because it's spread out, not 4080. So that allows you to reduce your expansion factor, so now you're storing less than 2 terabytes for every 1 terabyte you put in with still very high durability. So we did this. Sorry, did you have a question? Okay, so we did this. This was just like right off the bat, but it came up with some other interesting things. So there's proofs of retrievability. There's a lot of good survey papers out there. We went and read all the survey papers. This is actually one of the survey papers we read. If you recognize this is actually the Filecoin paper. But the Filecoin paper talks about reasons for what you need for proofs of retrievability. We ended up picking a collection of requirements where we are only ever storing a unique piece of data once because the data gets encrypted, Reed-Solomon encoded. We only have 1 copy of data ever. We're not storing multiple copies. And that means that the requirements for sealing don't apply to us. So we don't have any sealing step, and we don't need one even with the guarantees that we have around durability and audits. So we are still auditing data, we're still repairing data, we're still doing proofs of retrievability, but we don't have sealing. And that's because Reed-Solomon erasure coding is built in as part of our system. So what that allows for is where's the slide? It's after. Okay. So because of this, because we have all of these independent individual pieces, we're able to do some really cool tricks. So maybe the first thing to say, well, I'll come back to this. The first thing to say is there's a paper by Google called the MapReduce paper. In the MapReduce paper, Google talks about the long tail. And what they did is they over-request their request with MapReduce so that stragglers, there's inherent variance in the nodes in the network. And because of this inherent variance, they sometimes you end up having the worst of all of the nodes you're talking to, basically. If you talk to 5 nodes and you need the response from all 5, you're going to go as fast as the slowest of those 5, right? So what Google figured out is we'll make a request to 8. And then we can go as fast as the fastest 5 of those 8. And that's called long tail tolerance and tail cancellation. And what we do is we over-encode our Reed-Solomon numbers. So we upload to the fastest 80 of 110. And then we download from the fastest 29 of fastest 29 of 80. And so that gives us performance here. The green and the blue are us. The red and the yellow are Azure, and the this brown color is AWS. We are just faster than them across the board because we're able to leverage this parallelism. So I went a little bit out of order, but I guess I should say decentralized storage should be faster. It should be faster than the clouds because it's not hub and spoke. So when you think about the traditional cloud, when you store data, you upload it to S3, and then when you download it, you're going through these hops. So like imagine that the source is you and the destination is where your client, your customer is. And these are all the little routers in the network, right? So you're going through these hops. Downloading has to go through these hops. You have 4 hops to get to the data from S3 download for your customer in this trivial example. With storage, what we're doing is we're uploading to the fastest 80 of the node set that we stored, and then we're downloading from the nearest 29. And so that actually allows us to actually hit less hops overall. We're actually utilizing the broad scope and the parallelism of the network more thoroughly because we don't have to go all the way out to S3 in this case. So we actually have built an edge network. Any distributed system should be an edge distribution network. We should be going toe-to-toe with CDNs for every retrieval story, right? So that's what we've been selling. That goes back to some of the sales conversations that have been going really well. Customers are being told this by the Netflixes or the Cloudflares of the world, that you have this base origin and then you have all these other pops that you're storing data from. And what we're saying is, no, forget about that. Just store the data with us, and then you don't have to, you can eliminate a lot of this complexity. So
with this,
yeah, I'll stop there. Yeah.
do you have immutability?
Yeah, well, so we have a couple of different schemes. The main thing, I guess there's a couple of layers for what we have. What Filecoin calls a sector, we call a segment. And our segments are immutable and never change. But we also have an object, a key value store, a cloud object layer on top of that maps segments to objects with paths. And so you can go and override a path like S3. This is our S3 compatibility. And that replaces the old segments with new segments. And so then we garbage collect the old segments and the new segments now. So it gives the impression of a mutable key value store. And then we have access control on top of that to allow customers to do things like, we often get requests for read many, write once, or the worm model, right? So that is something that our access control model just applies on top of this. You can say this is undeletable.
Can you prove the immutability?
Yeah.
The way the sharding, right?
What?
The way the sharding in the
Yeah, you can give, like, we return all of the nodes that are hosting the data. If you request it, we return like the whole history of what's been happening. We return the audit, there's a bunch of information, and it sort of scales by how much investment you're taking in our network. If you're running your own satellite, you're actually doing all those things, right? So there's good stuff there. Who had their hand up next? I think.
Yeah, where do you track the metadata, and who runs it, and how do you govern that?
Yeah, so the metadata is stored in this heavy client. So essentially this is like, if you have data in a sector and you have that sector ID, where are you keeping the sector? Oh, one back. Oh, there it is. Where are you keeping the sector ID? People are keeping track of some level of information about where the data they just put is. If you have a 32 gigabyte sector and you've just stored it somewhere, or you have a collection of objects within that car file and you've stored it somewhere, you kind of care about what's in it. And so you can either store like a manifest with that or like whatever else, but you do need to keep track of like, this is my reference to get that data back. We have, as a user, helpfulness feature, our S3 gateway stores that stuff on this heavy client. So it is the user's responsibility to keep track of their heavy client, unless they're delegating, as it seems like some people are doing with like ceiling providers and stuff like that, to some trusted third party to do that. We are one such trusted third party. If you go to us1.storj.io, that is one of our 6 or 7 satellites, and you can create an account there, and that metadata is stored in a relational database, CockroachDB, which is horizontally scalable, multi-region, and it's backed up to our other satellites, so it doesn't. If one of them goes down, we can recover it. But that's where that metadata is it's heavy client specific. Yeah. There are opportunities for some synergy, I think, in merging that approach with how Filecoin does it to get maybe some greater decentralization.
So what are the financial incentives for large-scale enterprises to start onboarding huge amount of volume or capacity to the network? Is it like odd to start small and grow with the actual demand, or should an entity just hop on with 50 petabytes raw and say, hey, let's go?
Yep. So we just rolled out a program about 3 or 4 weeks ago for larger scale enterprises. So we took a really cautious approach to growing capacity, right? So we started off just very slowly growing, and we had some restrictions.
What's the difference between the two protocols?
Yeah. So when you look at our network, you're like, gosh, it's not very big, but the key thing is that it's utilized, right? And it's utilized with predominantly paid data, which is great because that makes everybody happy, especially storage node operators. If there's too much supply, not enough demand, people who don't earn any money start to drop off. And that starts to drive up the amount of repair we have to do in a bandwidth constrained environment. That's bad. So that's why we keep the balance like that. So on the public network, what we have is a /24 restriction, among other things, but it keeps any single node from getting more than one piece of any object so that any node can leave, any large number of nodes can leave, and you won't have an impact to durability. We did some math when the Russian-Ukrainian situation broke out, and we determined that if we lost Eastern Europe, we would go from 11 nines to 9 nines. And so we made some changes to how we distribute data a little bit, but now 11 nines, you can lose huge swaths, all right? And so that's the public network. And then we wanted to, sort of be able to onboard some of these enterprise customers, like, hey, I'm going to bring a 2.5, 3, 5 petabytes of capacity. Awesome. Well, that's erasure coded. That's 6, 9 petabytes of network capacity that we need.
Yeah.
It is much easier to go and get 10 large-scale providers to provide that versus hundreds or tens of thousands of small-scale providers, right? So we created this program to onboard the larger operators, and it's kind of like similar to some of the conversations that we've heard around like allocators and certified nodes and KYC on nodes. These are nodes that typically have extra value, like they're SOC 2 certified facilities. They're large scale, they're performant, but we know who they are. And when they bring on extra capacity, what we're able to do is remove some of the restrictions from the public network. Because if you bring 50 petabytes and you don't tell us, you fill up at the same rate as a terabyte node.
Yeah.
Meaning you will never, ever, ever, ever make any money. If you come on board through a commercial operator agreement, then great. We can have you fill up much, much faster. And there are customers who will say, you know what, I love everything, but I want SOC 2 certified facilities only. Well, great, we have lots of those. We'll just distribute it over those.
John, you might want to mention that most of the capacity that we have is from nodes that have already been deployed in Power for some other purpose. So basically, we're harvesting underutilized capacity as opposed to having people and then they can simply retire if they need that capacity back. So it's, again, getting more power, getting more capacity in the network. It's not going to be very difficult because the average node out there is one hundred.
So
In the world, right?
I used to run the Storj node like for a year,
Mm-hmm.
and I didn't really make a lot of money, like maybe $100 or something.
Mm-hmm. Yeah, so
That was 3 years ago.
yes, and yeah, 3 years ago, that sounds about right.
And now
Yeah, I don't know if are we told to.
No, I have a real question.
Oh, okay, sorry.
And so back to the question that he asked, so how much is it paid now?
So on our public network, we pay typically $1.50 per terabyte per month for data stored, and that's unrated raw JBOD capacity. So we don't require anything special. That can be a Raspberry Pi and a 2 terabyte external hard drive. And we pay typically, I think we're right now at $4 a terabyte for egress bandwidth. But that's been kind of coming down steadily because the amount of egress bandwidth on the network has been coming out. So we want to make sure that we have a good, healthy earning ratio across the board.
Do you know who all of your storage nodes are? Are they all KYB, KYC?
They're not. The overwhelming majority of the nodes are perfect strangers. Some of them, provide an email just so that they can get like updates and things like that. But we do know who the large-scale commercial operators are. So anybody who's bringing more than a couple of petabytes of capacity, we definitely know them.
Right, and I guess I'm just curious, on your enterprise, so I'm imagining, like these larger enterprise deals that you're POCing right now, or any existing large enterprise customer limits their storage to your commercial operators.
Not always. I mean, there's some that are limiting to like our SOC 2 certified collection, but we have a number of those logos came on the public network.
In use case specific, if they're streaming video, they don't care. They just want
Yeah,
to make comments. If it's backup of sensitive public data, obviously they want to do it.
Yeah, because I think of other things in sort of my enterprise experience, large enterprises want certain legal assurances that like, hey, you're not breaking the law, you didn't fund this with drug money, you're not employing child labor, right? Like simple reps and warranties.
Yeah, in terms of like the commercial arrangement, we have pretty mature contracting process for large enterprises. We can pass the compliance sniff test and we can jump through all the typical enterprise sales cycle hoops. What it comes down to in terms of node selection, it really does come down to what is their level of risk tolerance. Because to be honest, the difference between storing data restricted to the SOC 2 certified nodes and the public network is nothing, right? They're only storing encrypted bits of erasure coded bits of encrypted data. So the bigger the network, actually, the higher the fault tolerance is in terms of loss of nodes. Everything that we do meets our SLAs, but functionally it's no different.
Well, and we do have a terms of service for our node operators that are like some of that basic stuff of like you're not using this illegally and you are it's covered by our terms of service for node operators.
Well, that's what I was getting, is how do you get them to sign up for that without KYC?
So it's kind of like a click through on a node by node basis. And the number of things a node actually has to do is just turn the node on and don't mess with it. Right? And that's like, these are really simple things to operate. It's a little agent, it runs in a Docker container, and
And they click through using their wallet as identity? Or what's that, when you say they click through, how do you identify who they are?
so we've sort of got the blanket, if you're running a storage node, these rules apply.
I see, so they don't even have to click through.
They don't need to click through.
No.
There is a form that they fill in to get an auth token to get their certificate signed by us. So we could make them click through. We have that injection point if we wanted, but we haven't used that.
But they do have to fill out some form.
It's like a web form. We don't have anything other than you're not a robot on it.
Yeah.
I mean, like when you download
Yeah.
the terms and
Yeah,
conditions,
that's
click,
right.
click, click, next.
But we don't do it the next. Like, it's just sort of more blanket, like you
not
run
a
it,
robot.
it applies to you.
That's right.
I'm not a robot. But the idea is that, for the most part, if you want to work with a storage operated heavy client, I pointed this like the wrong slide is up, but it's not. Imagine the satellite is up there and I pointed at it. If you want to work with a storage satellite, then that's the process you do. Somebody else, like if you want to work with the University of Edinburgh's satellite, they may have entirely different processes for that, and that's up to them as a heavy client operator. And so you figure that you've got this pool of 20,000 nodes out there that can work with any satellite out there. The ones we run, the ones people we know about run, the ones people we don't know about run. And the onboarding process can be unique per satellite.
And is the satellite setting the price or is only storage?
Yes.
Yes.
The satellite,
Satellite sets the price.
Satellite sets.
So back to your question earlier, what is all this? We set the price. Well, for the satellites we run, we set the price, and we tell the nodes, this is how much we'll pay. You want to join our service? Join the service. And right now, what we've seen is we started off with a much higher price point, particularly around egress. And what we wanted to do is over-incentivize growth, right? This is the Filecoin Plus analog. Make it worthwhile for people to join in advance of demand, because you can't have a whole bunch of riders and no Uber cars, and you can't have a whole bunch of Uber cars and no riders. This is how we bootstrap both. And then over time, we've reduced the incentives on the storage thing and just watched what happened, right? And so far, we've seen a lot of, this is terrible. What are you doing to the little guy? But nobody's left the network, right? So, people will protest anytime you change the amount of you pay. But if we're incrementing the usage so that they're actually making in the aggregate more money, that's great. And it allows us to have sensible COGS as an actual going concern.
There's some SPs in the room. How do you see the integration with Filecoin? Can you talk to that? I don't know.
So there are some easy surface opportunities for integration here. So some of these are like using Filecoin as swap space, or using Storj as swap space for Filecoin to help onboarding acceleration, right? That nice web interface, you upload your data and then magically it percolates back to Filecoin. Thinking of Storj as an L2 for Filecoin, right? In terms of like looking at how you want integration to be done, seeing us in that space. We're sharing all this stuff, it's okay. But I can smile too. So, yeah, the additional earning opportunities for storage providers, right? That's a no-brainer today. If we were to see a customer come through with, 100 petabytes, the fastest path for us to get 100 petabytes onboarded, frankly, would be to call you and say, hey, do you have any service providers who would be interested in participating in the network to the tunes of multiple petabytes? And that is what we would do. So when we launched our commercial node network, one of the things we noticed is we actually got two Filecoin miners. We're like, hey, I have infrastructure that isn't Filecoin. Is it okay? And we're like, yes, it is. Tell us more, right? And one of them was in India. They had ISO 27001. One of them was in the U.S. and they had SOC 2. Like, it was, yay, total win.
So this may be an implementation question then, but how would you ensure that ESP that's running, let's say, the satellite node, could control which backend systems that they want to store?
Yeah, so the cool thing is that they don't have to, right? They can just run the storage node piece. So in our peer classes, you can run only one or any combination of those. So you can run a satellite, you can run, and just a satellite, you can run a satellite and edge, or you can run a satellite, edge, and nodes. So we run satellite and edge, but we don't run any nodes.
Maybe a thing worth pointing out is we don't have the concept of pledged data. We have nodes that are accepting data or not. And if a node is accepting data, the only data that matters is data that has been accepted. And we pay for accepted data. Once the data is accepted, that counts against their overall usage and with their billing and accounting and so on. But they're just advertising whether or not they have data or not. And so we have a flag that controls how much of the disk is allocated for storage. So when you start a storage node, you say, only 10% of my disk gets storage. And then the storage node will essentially say, hey, I'm free for data up until that 10% is full, and then stop.
So so if I understand this correctly, and I'm also trying to say this because I want everyone else to think through this too, is like the satellite would drive data into the network, but in the end, the network itself decides where the pieces land, and the pieces will land through a deal that comes up to Filecoin, right? So there's some integration that will need to happen between the two stacks to do the deal.
Yeah, that could work.
Etc. And because in the Filecoin ecosystem, right now, our biggest onboarders are the storage providers. They bring in a deal to the network, and they also control which end systems will be receiving those copies.
Sure, that's
so this is
doable.
a little bit different where an SP comes in, it's like, oh, I'm just going to, let's say we have that integration, they're just going to receive deals.
Yeah.
Correct.
And they're not going to know where it's coming from. It's going to be
Well, they could do it that way, but they could also specify that they want to be. We have the concept of placement classes essentially, and what that allows for is it's actually a scripting language that we wrote. You can basically describe a placement script for how the data gets stored, what types of operators the data gets stored on. And so if a storage provider came and said, look, I want to share my storage with people who store with a specific type of placement, we have a very rich ecosystem of being able to describe who that node will accept data from and for what reasons.
Yeah. A placement could be just one service provider, for example. So if you had 10 service providers onboarded, you could see them and say, I want this data to go to that service provider, and that service provider. And you could either replicate, if you wanted to, like a full copy on all three, or you could distribute one data set across all of them. And then if they wanted to, they could actually run the edge services. And, you know, there's a lot of flexibility in terms of like architectures. So, okay.
How is crypto integrated?
Yeah. How is crypto in the thing? So there was a lot of conversation earlier. Oh boy, people are crypto allergic in enterprise. This is a true statement. So on the satellite side, we give you the choice of being able to pay in crypto or pay with a Stripe integration or pay with a invoice. So we're really easy to buy from. And on the back end, we pay the storage nodes in crypto because if you have to pay 22,000 nodes operated by 10,000 people in 105 countries, there are zero products other than crypto to actually do that and not go out of business. So it is a fantastic use case for that.
But more specifically, we don't have our own blockchain. So we're blockchain agnostic in some sense. We talk in our paper about how we could swap out for live goats, though live goats are not very subdividable. So if there was a different blockchain or something that made better sense, that's...
But you only use it to pay the SP.
That's right.
And then I assume it's like a stable coin 100 times out of 100 or 99% out of 100?
It's a pre-mint, so we just have a fixed supply.
We quote rates both for customers and supply in dollars, and then we pay it up.
We keep all of our accounting happens in USD,
at least what
and
we
then
saw,
at the
people
point
want
of
stability for planning.
yeah.
So it's really just a.
They don't want to speculate.
It's an utility token.
Yeah.
Yep.
Just want to understand, it's your own token.
It's our own
Yes.
token. We all of our billing internally happens in USD. So when someone sends us storage token, we immediately we look at the current spot price and put a deposit in their account for that much USD. They have a USD invoice, and then when storage node operators get paid, we're keeping track of how much USD that storage node operator has earned. And then at the point of transfer, we look up the spot price and send them that much storage.
I see. So it's essentially fiat payment, just real-time currency conversion. And then if they don't want to hold that currency risk, they just sell it to you.
In fact,
Correct.
many node operators give us their exchange address, and they just...
Yeah. There are, like, if anybody wants to, like, sync up afterwards, there are nuances to that. And so we have sort of a reverse staking mechanism called held amount that sort of builds up a deposit. And some other things just to sort of limit, you know, certain types of gaming activities. But yeah, there's
The
a,
operator is thinking of it as a single revenue stream, two different currencies, as opposed to two revenue streams, correct?
correct. Yeah, single revenue stream.
And then how do you ensure the durability of any single node, or do you really not care?
We don't.
We don't care.
We don't care. We do not care. We actually, our data science team that picked our Reed-Solomon numbers actually had a double counting bug, and we're actually way more durable than we even think we need to be. The amount, right now we could lose all of Russia and be completely fine.
Yeah.
And Russia is not underrepresented. Like, there are many Russian node operators.
Yeah, that Eastern Europe zone is about 10% of the network, just to give you a sense of scale. Boom.
Good, shut them off.
Yeah, seriously.
For the
That's been...
On understanding of the mechanics, I got a couple of questions. I'm going to start with the first one. So I deploy the Docker container and give it the allocated space, and as you say, don't touch it. I'm a bad actor, and I'm going to go in there and turn some of the allocations that I see that you guys make in my file system into sparse files.
That's right. What?
How and when do you detect it?
Yeah, so we do, this is one thing that we do. We found really great success with what we call stochastic auditing. What that means is we're not actually going and doing a zero knowledge proof of all of the bytes consistently every epoch window or anything like that. What we're doing is we're saying if a node, node operators fall into three classes. They are either altruistic, they're going to just run the code that we gave them. They're either going to be rational, which means they're going to respond to incentives, or they're going to be Byzantine and just try and mess with us. And what our thesis is that most node operators are rational. By modeling the network that most node operators are rational, we're just trying to provide the right incentives so that a rational actor will do the right thing. Though we have to keep in mind that some node operators will be Byzantine and just cause chaos for chaos's sake. In that model, what we've done is we've set up a system that essentially, given the amount of data on the network, at random picks a byte. And then it goes and it audits that byte across all of the nodes that might be storing a part of it. And that system is running really fast constantly all the time, so we're checking random bytes all over the place. And if a node operator in its grouping, like we upload to 80 nodes at a time, so we're going to go and try and download all 80 pieces, all 80, whatever we need to reconstruct that byte of the data. There's an algorithm called Berlekamp-Welch, which is the algorithm for detecting error in erasure codes. And using that in a combination of that with our authenticated encryption, we're able to actually detect not only which piece is wrong, but which node did it. And then they get what's called disqualified, which means they are permanently kicked off the network. So a node operator is given maybe 1 or 2 chances to fail an audit for, there's different types of failure. If a node is offline, then we're more lenient with that. But if they went offline right when we asked them about a specific piece, then they're in what we call containment mode. And that means that, they might be trying to get out of this audit. So we're going to keep trying that audit until we get an answer from them. And if they're not able to answer that audit, they are disqualified and they're kicked off. John mentioned the held amount. Node operators accrue over time a certain amount that is that they'll earn back if they are stable and well behaved on the network for long enough. And from that incentive perspective, what happens is if they are disqualified before they've earned back that held amount, they lose it. So there's a bunch of financial game theory going into trying to make it so that the person who's thinking about what's best for them decides not to do that.
So in your sharding scheme and erasure coding, you can lose n number of shards and still be able to retrieve the data. When you go n plus 1, you're able to detect the error, but you can't fix it anymore. What are those 2 zones of error detection? So what I'm wondering is how many shards, if it's 200% redundancy spread out to erasure coding, I would assume, I can correct up to 39 missing chunks of data. When I go to 41 missing chunks of corrupted decent data, I can tell that it's broken, but I can't fix it.
That's right. No, that's a very astute question. So the thing that we have now in these cases where basically the way that the Reed-Solomon construction works is it looks like votes. And we're assuming because the satellite was responsible for choosing which nodes were uploaded, node operators don't have a say about which nodes are selected for a particular upload. So we're assuming that a majority of the nodes are rational and not colluding. That's essentially a 51% attack if they're colluding, all of them. If they're all colluding, then it's true they could control some of the thing, but that's not the case in any of the queries that have happened.
That takes me to my next question.
Okay.
So the satellite node has the mapping of a particular data set.
Yeah.
And if I attempt a partial retrieval, how could a bad actor do some kind of inferencing to figure out which node operators have the data so that I can target them attack to disable or to truncate data files in there?
We've spent a lot of time trying to make sure that node operators have no idea which pieces go with each other. However,
The satellites have to know.
satellites do have to know, right? That's true. And so there is a level of like a customer has a level of trust with one of these heavy clients.
Yeah.
And if you don't trust your heavy client, then there's really there's not much more to do about it. But as long as that heavy client is defended like any other cloud service or any other like software as a service or any other infrastructure,
Filecoin for a backing store.
or has Filecoin for a backing store, sure, then as long as it's defended, I mean, that data is still all stored encrypted.
Yeah.
And so the only thing that matters is the only way that a node operator would be able to like figure out who's doing it is if they have state actor level network penetration, like they own all the routers and can do timing attacks or something like that, because none of the data that's stored on the storage nodes is able to be correlated to which one is which. So the only way could be access patterns, if that makes sense.
Yes, oh, exactly, that's what I'm thinking of. And I really like what you guys have been doing. I've been tracking it for a long time. And I was just talking with the team last week about how we could fix so much of the retrieval CDN stuff that we're spinning lots and lots of cycles doing L1, L2 Saturn, and the consensus is it's neat and it's interesting, but probably isn't going to work where you expect it to. Whereas if we could tightly integrate some of the storage type front ends and use the Filecoin back end, the tier 4 archive stuff, actually call it stack and mind meld somewhere, even in terms of the tokenomics and the reward cycles, if you're agnostic. That's win-win-win all the way around, and though it's unlikely, there are attack vectors at the state level on Storj's infrastructure, I think, may not be able to change and alter the data, but we can push it to the point.
It's true that we have some vulnerability to state level denial of service, but then again, who doesn't?
Right, and that's not a feature we can generally sell because everybody's buying it with those things.
That's right.
Today.
That's right.
But from a purist philanthropy.
Yes, sure, of course.
So I see a tremendous amount of opportunity there to mind meld some of these things together and solve the CDN side and then make the demonstrably provable immutable archive, which storage is conceptually there. But I think there's a couple of wiggly bits there where if I were in the State Department to figure out a way to, might not be able to change the data, but I can break it.
Yeah, that's true. Denial of service is a tricky one to solve. Even with Tor, that's hard. Yeah.
What's the next step then, the action that we should take as a community to go vet something out like this?
So we put together some, high-level architecture diagrams just to sort of explain, like, this is what our network is. These are the components that you see. These are the capabilities around grouping nodes. And then, this was sort of a view in terms of like, well, if we were to look at service providers and distributing data over Filecoin storage providers, how would we do that? How would that work? Who would run edge? So we have some initial thoughts that we want to bring to the table. But really, this is a great conversation. Like, the thing that you're asking is the thing that we're asking too. Like, this seems like a smart thing to do, and we should do it. And this seems to be the place to talk to the people who would know how. And so that's what we want to do.
Ways, and again, keep the target on the other guy's back.
Right. That's exactly it.
Yes.
Yeah.
Yeah, no, I think you did even have a slide that was like,
Where'd it go?
You did have a slide that was like, where do we go from here?
Oh, where did
that
I?
slide?
Did I
Where
delete
did
that one?
it go?
Yeah.
We did have
Where
one.
did the slide go?
Where did the slide go? Where do we
Yes.
go from here? Yeah.
Yeah. I think I got replaced with just questions.
Yeah.
But yeah, sort of just, I think that's what we want to do, right? Is we want to do some whiteboarding. We want to just, figure out what the fastest path is to get some quick wins.